Hello everybody, welcome back. Today we are going to go ahead and start Unit 4, and with day 1 we're going to start with slope. Okay, so slope is something you've seen before, but we're going to formalize it a little bit more. So let's start with what is slope. Slope is the ratio of the vertical change to the horizontal change from point to point. So we're talking on a graph here, or on any kind of line. And when we go from one point to another, the distance it is vertically to go to that next point and horizontally makes up our slope. Okay? It's also known as rate of change. So sometimes you'll hear the word rate of change more than the word slope. And rate of change is usually, it means the same thing. It's still talking about slope, like how much is it increasing or decreasing by. But rate of change is typically used a lot more when we're talking about real world examples. So because they want to know like how something is increasing, decreasing, the change that's happening, and at what rate. More stuff about slope. So we use the M as our notation for it. So whenever you see an M, that's standing for slope. And there is a formula to go with it. The formula is y2, which is the y for your second point, minus the y for your first point. So that's what the 2 and the 1 stand for. They're not exponents. They're just differentiating which y for which point. Over the x from the second point minus the x from the first point. So basically, that's going to create your difference, the change in the horizontal and the change in the vertical. Change in the vertical over the change in the horizontal. Most of you probably know it as rise over run. Okay, which you can still use when you have a graph and you have that visual for yourself. That's really fine. However, this year you're not going to have as much visual, you'll have more algebra, and this is the one you're going to want to use. This formula is also not provided on the formula sheet, so this one will need to be memorized. Luckily, we're going to practice it so much it'll be in your brain forever and you will never forget it, because you can't, even if you wanted to. So that's the formula. Next page. So there are different types of slope depending on what kind of line, what the line looks like, and you should be able to recognize these types of slope visually, as well as from an equation, or just if I just give you a number for the slope, you should be able to tell me what kind of slope it is. So these are the different lines. When it looks like the line's going down from left to right, so if you just read it across, it's going down here, that's a negative slope. Okay, and what that looks like is basically it's going to be a negative number when you calculate it. Okay, when it goes up from left to right, that creates a positive slope. So when you calculate it, it will be a positive number for your slope. All right, those are the most common, negatives and positives. The special kinds are these. When we have a vertical line, that is an undefined slope. Okay, because what happens when you calculate the rise over the run, the rise is happening from point to point, but there's no run. You're not going left or right with it. So that means you're going to have a number over 0, which we can't divide. That's why it's undefined. And the last one, let me move this thing out of the way, is our horizontal line. So again, when you calculate this, you don't have any rise, so you have 0 for your rise over any kind of number for run. So you have 0 over a number, that always comes out to be a slope of 0. Horizontal lines will always have a slope of 0. Undefined lines will always be vertical. This is written in my room in 2 locations as of right now. And there will probably be a third because I'm probably going to make a poster about this very soon. So be aware of this, please. Slope dude, my favorite kind of dude. So if you're having trouble remembering what each one of these are, you can draw a picture. So I gave you a circle, but you guys are going to write it in. So we have a negative slope, which would be his first eye, and we're going to draw the eye row over it of a negative line. Okay? The other one will be positive, and so we draw a positive line. His nose is going to be made up of a vertical line, which is an undefined slope. And his mouth will meet our horizontal one, and we'll add like little cheeks there. And those have a 0 slope. So When in doubt, ask Mr. Slope Dude. So, there are different ways we can find slope. One is from a graph, and when that happens, we basically just pick any 2 points from the line. Any points from the line. I always suggest picking ones that are on those like grid intersections because it's clear, like the numbers are very, they're integers rather than decimals or fractions. So try to pick them on the intersections if you can. And then basically you're going to count vertically the distance between the points, like if you had to go up or down, and count horizontally left or right. And then you're going to put the vertical distance, your rise, over your run, and that's going to be giving you your ratio for your slope. Now, things to keep in mind. If you move up, you're moving positively, so that means it's a positive number. If you move down, you're moving negatively. So, for instance, between your 2 points, if you had to go down like 5 points, that's a -5 for your vertical distance. Okay? Same thing with horizontal. If you move to the right, you're moving positively. And if you move to the left, you're moving negatively. Okay? So you got to be careful about those negatives and positives because they will make a difference for your rise and run. The last thing is you want to make sure you always simplify your slope. Okay? Always simplify it into the simplest fraction you can. And if it comes out to be like 4/1, make it 4. Okay? Always give it in simplest form. Alright. I'm flipping through your notes just to make sure everything matches. So, here's an example. We have to find the slope from the graph. Alright? So, you want to go ahead and pick 2 points, and I think I picked 2 points. Yeah. I picked this one, and I think I picked this one. Yeah. I try to go for intercepts because those typically cross very nicely at a number. However, not always, but I look at the intercepts first because they're just like nice, clean points you can always find. So basically, I'm just going to go ahead and figure out what's going on here. So I always start left to right, but it doesn't matter because it will always simplify the same way. But I just go left to right. So here, I'm going to do the rise first. So I'm actually going to go up 1, 2, 3, 4, 5. So my rise is +5 because I went up 5. And then from there, I'm going to go to the right to get to my next point. 1, 2, 3, 4, 5. So my run was also a +5 because I moved up, which is positive, and to the right, which is positive. So to create my slope, I would just write 5/5, which I want to simplify. So my slope is 1. Okay? You guys are going to try the next one on your own. Give it a try, and I did make clear points for you on this one, so it wasn't as bad. Okay? Give that one a try on your own. Now, finding slope from an equation. This is the equation you're probably going to see most often. This is slope-intercept form. And this whole thing is slope-intercept form. And what's great about it is that the stuff in this form is actually very clear to find on a graph. So I'll teach you a couple other forms tomorrow. Well, not tomorrow, but like next video. But this one is probably the most common. And if you can do slope-intercept form, you can do any of the problems that have to do with lines. Okay? This is also probably the form you're going to use most often for using the calculator. So what's great about it is that it says slope-intercept because it contains your slope, which is in red right here, the M, and your y-intercept, which is the B. Okay? So that's what's great about it, is that it's got your slope and your y-intercept, so it's got plenty of stuff that you need to graph. Okay? If you had to graph. So, if we had to find slope from a line, which is even easier, our main focus is to get it in slope-intercept form, and that way we can figure out like what the m is. M is always the one that's going to be multiplied with x. So, if we get an equation like this, 3x minus y equals 16. By the way, this is another form you're going to learn. It's called standard form. But for right now, we're going to pretend like we don't know it, because we don't. Our job is to isolate the y. Get y by itself. It should come out to be in slope-intercept form, and then we can just identify the slope. So, going back to literal equations that we learned a couple units ago, I'm trying to get this y by itself. So, the very first thing I need to do is get rid of this 3x. So what I do is I subtract 3x from both sides. I'm not going to be able to simplify this side, so I just have to leave it here. But these 3x cancel out. So I'm left with negative y equals negative 3x plus 16. So we are pretty close to slope-intercept form already. The only thing is that we have a negative y. I need to get rid of that. So I'm actually going to divide every single term by negative 1. You could also multiply every single term by negative 1, and it would work. But if I'm going to divide this y by it, I divide the whole side, which means every term. Okay? So here the negative cancels out, the negatives cancel out here, and this one changes. So I get y equals 3x minus 16 as my slope-intercept form, which means that this number right next to the x here, which should pop up, there we go, is my slope. So my slope is 3. Okay? And now you guys are going to try this one on your own, and we'll go over all of these before we do the activity tomorrow. Don't worry. Now, finding slope from 2 points. Okay? You're going to use that formula that I showed you at the beginning of the video. And then you're going to either pick 2 points if they give you a graph or something, or you designate which one is point 1 and which one is point 2. So point 1 is going to be your x1 and your y1, whatever those numbers are, and point 2 will be your x2 and y2. Okay? Is there more here? Nope, I just made a slide just of that. Okay, so example. Find the slope of the line given it crosses, well, I forgot to say a lot of stuff, that it crosses through these 2 points. Okay? So, I have 2 points. I can use that formula. And I'm going to designate stuff as y1 and y2. Whoa, things are just popping up now. Ignore this. Actually, don't ignore it. I'm just going to go back. So, I'm going to make this one y1 and y2, like x1, y1, point 1, whatever you want to call it. And this one's going to be point 2. Not that it matters, but you do need to make that distinction now. Whichever one's going to be point 1, you have to stick through it throughout the entire problem. Okay? So you could work it out a little bit, like pick your point 1 is different than mine, which is totally fine. We should still get the same slope because these points are on the same line. Okay? So this one's going to be point 1, this one's going to be point 2, which means that x1 is negative 1, x2 is 6, y1 is 4, y2 is 3. So I'm going to use this formula to plug the stuff in and then simplify it. So y2 is 3 minus y1, which is 4. x2 is 6 minus x1, which is negative 1. This is where the parentheses matter because this minus sign is part of the formula. It is not part of the value. Okay? So now I have m equals 3 minus 4 over 6 minus negative 1. That makes a difference. Okay? Top comes out to be negative 1. Bottom comes out to be positive 7. So my slope is negative 1, 7. Okay? Go ahead and try this last one on your own. If you have any questions, write them down. Otherwise, we will talk about it next class, and we will do some practice with it. Okay? I will see you guys later. Bye.